Today we're going to go ahead and take a look at solving quadratic inequalities. We're going to do it from a graphical perspective and an algebraic perspective. We'll also be graphing quadratic inequalities. And that's what we're starting out with here. So for the most part, I want to figure out the x-coordinate of my vertex. So I'm going to do negative b over 2a. So I get the opposite of negative 3 or positive 3 over 2 times a. So I want to make sure I choose three numbers on each side of 1.5. So choose three numbers on each side of 1.5. Then once again, I could plug this into my y equals and do my second window table set, started at -1 and look at my table. And then I could just plot these points. Left 1 up 6, left 0 up 1, right 1 up 0. My vertex, which I could go ahead and plug 3 halves in to be able to figure out my y value, but it won't show up in your table on your calculator. Now I want to go ahead and plot those points. I also have the shading down here, and we'll talk about that in just a bit. Now, notice it's only a greater than, not a greater than or equal to, so that means a dotted curve. So if it's a greater than or less than without the equal to, it's dotted. If it's a greater than or equal to or less than or equal to, then it's a solid curve. So if you just plot your points anywhere along here, and you have for your problem, you're looking for the y values that are greater than that. So if I'm here and I'm looking for y values greater than that, that's up here. If I'm here, I'm greater than that, that would be up here. So in other words, I want to be everything above my parabola, so that lets me know I am shading above. And that works great when y is on one side by itself. Now, a second way you could have done it is to try a point that's not on your parabola. And I always like to try the point 0, 0 if at all possible. Then you can plug the y value of 0 in, your x value of 0, your x value of 0, and that's what we have right here. Now notice that gives you 0 on the left, greater than 2 on the right. Excuse me. Which is not a true statement. 0 is not greater than 2. So we tried a point here. It made it false, doesn't work. So that means you got to shade the other side of the inequality. So that's another way you could go ahead and decide which side to shade. So see if you can do this problem without watching the video and then watch it quickly. So once again, negative b over 2a. Plug it in, simplify, we get 2. Try three numbers on each side of 2. Plugging all this into your y equals on your calculator right here, doing your table set starting at -1, looking at your table, which is once again second graph, you get these points. You plot these points, left 1, down 3, left 0, down or up 2, right 1, up 5, and so on. Because it's an equal to here, we know it's going to be a solid curve. Now we want y greater than that, so we should be shading above our curve. And you'll see that that's what we have here. We are shading above a curve. Here's our curve. We want to be shading above, so that's up. Here's your curve, shading above because of the greater than. Or once again, you could try that point 0, 0. If you try, and we can do that, if your parabola went through the origin of 0, 0, you'd have to try some other point. So just be aware of that. If you plug y being 0 in up here and x being 0 here and here, you would get this. So you get 0 on the left, greater than 2 on the right. True statement, so you got a shade, oh no, sorry, 0 greater than 2 is not a true statement, it's false. So we tried this point, it did not work, you'd have to shade on the other side. So now we're going to look at solving quadratic inequalities, getting our answers from the graph, but it's not technically graphing a quadratic inequality. But we're going to use our quadratic graph to be able to answer our question. So we pretty much want to graph this so that we can solve our original problem. Now, I like to have the y on the left side, the function on the right side. Notice the pointy part is going towards the y. So when I rewrite it, the pointy part needs to go towards the y. Then you still do that negative b over 2a, and then you want to try 3 numbers on each side, and then you want to graph it. Now, if we're graphing this for real, we would know that it would have to be dotted and we'd have to do shading. All we're trying to do is to look at our graph and get our answers. So when we are looking at our parabola being greater than 0, that means we want our parabola to be above the x-axis. Well, isn't our parabola above the x-axis in these situations? We're above the x-axis in both of these highlighted yellow situations. So when we're at 1 and to the left of 1, and when we're at 3 and to the right of 3. So to the left of 1, I would say that's x is less than 1. To the right of 3 is x is greater than 3. It's two totally separate regions, so I have to write it as two totally separate inequalities joined by an OR statement. So see if you can graph or solve this one by graphing. So first of all, I'm going to put the y on the left side, do negative b over 2a, make my table, plot my points, and I get this. Now, as I look here, I want the y value greater than, I want my y value to be greater than this. So in other words, I want to know when, just a second here. Yeah, sorry about that. So as I look here, I want my parabola right here, the parabola, to be less than 0. So that means I want the parabola to be below a height of 0. So where is my parabola below 0? That's only between 2 and 3. So if I write that answer, it's only one region. I'm in between negative 2 and negative 3, so I would get this. So now, instead of using a graph, let's try to look at this algebraically. For the most part, I want to factor it, put my points on a number line, which will divide my number line into regions that work and regions that don't. So to factor this, remember to factor it, you want to have 0 on one side. So I'd have to go ahead and subtract 2 from both sides. I get this. Then I can do my AC factoring. I'm not going to go through that process, but we would get this. Then you want to set each factor equal to 0. Set the first parenthesis equal to 0. Set the second parenthesis equal to 0. So 1 and negative 2, divide your number line into regions that work and regions that don't work. So now we want to go ahead and take our inequality that we have, which is, I'm going to go ahead and deal with this. It's an equation, but remember, if I brought this down, I'd have a less than or equal to here. So I'm going to write this x minus 1, x plus 2, less than or equal to 0. Now, all I'm going to do is put that on my number line, divides my number line into 2 regions, or 3 regions. So I'm going to try a number from this region over here. I could try like negative 3. Negative 3 minus 1 would be negative. And just a second, I thought I switched colors, so try this region, plug in negative 3 is negative. Plug in negative 3 here and add 2 is negative. A negative times a negative is positive, but I need something less than 0, and a positive is not less than 0. So I tried a number here, and it didn't work. So I'm not going to go ahead and shade. Now I'm going to go ahead and try a number in between. I'm going to try something in here like x being 0. Well, 0 minus 1 is negative. 0 plus 2 is positive. A negative times a positive is a negative, and I need something less than 0, which is a negative. So I tried a number in between, and it worked. So that's where I'm going to shade. Then I'm going to go ahead and try a number to the right over here. I could try like 2 or 3 or even 10 billion because I got to just try something greater than 1. So if I tried 2, 2 minus 1 is positive. 2 plus 2 is also positive. And a positive times a positive is a positive, but I'm looking for something less than 0, so a positive is not less than 0, so it's not going to work, so I don't shade over there. So now I go ahead and write my answer off of my number line. I have one region in between two numbers, so I write it as one compound inequality. So try to do the last problem on your own and then watch the video. So set equal to 0 by adding 6 to both sides. Do your AC factoring. Set each factor equal to 0. Get your critical points. So -3 and -2 divide your number line into regions that work and regions that don't. Now, could we plug it all into the original problem? Yes. But if we plug it into our factored form here, and notice we had a greater than, and we'll have a greater than, so I'll bring that down, x plus 3, x plus 2 greater than 0. I'm going to check it into there. So we could try something in this region over here. Something from over here like -4. -4 plus 3 is negative. -4 plus 2 is negative. A negative times a negative is a positive. And I'm looking for greater than 0, which a positive is greater than 0. So I tried a number over here, and it worked, so I'm going to shade there. Now I'm going to try a number in the next region. I'm going to try something in here, like -2.5. -2.5 plus 3 is positive. -2.5 minus 2 is negative. A positive times a negative is negative. And I'm looking for something greater than 0, and I just got something that's negative, so that's not working. So we're not going to shade in between because we tried it and it didn't work. Now we'll try a number to the right. I could try any number to the right of 2 and it would not make a difference. I'm going to go ahead and try 0. 0 plus 3 is positive. 0 plus 2 is positive. A positive times a positive is a positive. And I'm looking for something greater than 0. And I got positive is greater than 0, so it does work. So now I have two totally separate regions in my number line that work, so I need to write it as two totally separate inequalities. So I got to be less than -3, so x is less than -3. And I got to be greater than -2, so I go or x is greater than -2. Now notice up here, there was no equal to, only a greater than. So notice that these don't have a greater than or equal to, only there's no equal to here. Now over here, I had a less than or equal to, so that means I'm including my endpoints, so they're both have the equal to part here.